problems based on electrons and photons chapter class 12. So let's go with the problem. First problem is light of wavelength 5000 angstrom and intensity 39.8 watt per meter square is incident on a metal surface, and if only 1% of incident photon light emits photoelectrons, the number of electrons emitted per second per unit area from the surface will be nearly, and we have four options here. So let's first understand the problem here. Wavelength of your light source is given, intensity is given, it's watt per meter square, or can be replaced by joule per meter square second, and this is related to photoelectric effect, where some light source is incident on your photosensitive material and some photoelectrons are emitted. The number and photons is nothing but a packet of energy. So according to Planck's theory, energy is radiated in the form of packets, small packets or small quantas, and each quanta is said to be photon. So out of total photons emitted from light source, only 1% of the photons are responsible for emission of electron is given in the problem. So let's go forward. First of all, we have given that is wavelength 5000 angstrom, 5000 into 10 raised to minus 10 meter, intensity 39.8 watt per meter square, and we are asked to find out electrons per unit area per unit time. So here is a light source which is incident on metal surface, and out of this the metal surface will emit some electrons known as photoelectrons. Out of all the photons which are incident, only 1% are responsible for emission of electron. So now let's first find out the energy of each photon. So energy of each photon will be equal to h nu, where h is Planck's constant whose value is 6.62 into 10 raised to minus 34 joule second, and nu is frequency of light source that can be replaced by speed of light source upon a wavelength. So now the formula turns out to be h into c by lambda. Inserting the values, so inserting the values of h, that is 6.62 10 raised to minus 34, speed of light 3 into 10 raised to 8 meter per second, and wavelength, we get the energy of each photon, that is 3.972 into 10 raised to minus 19 joule. So this is the energy of each photon which is coming out from the light source. Now total energy to be emitted is how much? 39.8 joule, and number of photons for this much energy will be nothing but total energy divided by energy of each photon. So approximately 39.8 upon 3.972 into 10 raised to minus 19. So 10 raised to 20 number of photons are to be emitted if we want energy of 39.8 joule. So 100% photons is equivalent to 10 raised to 20 number of photons. So now out of this 10 raised to 20 photons, only 1% are responsible. So 1% of 10 raised to 20 is 10 raised to 18. So each effective this, let's call this photon as effective photon, which is responsible for emission of electron. So each photon will be responsible for emission of each electron, one electron. So therefore 10 raised to 18 photons will radiate or will help 10 raised to 18 electrons to be emitted from the surface. So we have our answer, that is 10 raised to 18 electrons will be emitted per unit time, per unit second from this metal surface. Thank you.